the most expensive seal is the one that fails.
Yeah.
So
Yeah.
when you go through and you're trying to design something that's going to be used in a application, whether it be critical or not, a very inexpensive component like a seal or an O-ring can cause a lot of non-productive downtime,
Hmm.
safety concerns even, and the like.
Nathan, thanks for coming and joining us today. I'm Zach Robinette with Performance Seals. Nathan, you want to introduce yourself?
Sure. I'm Nathan Sowder with Parker's O-ring and Engineered Seals Division.
Nice. Well, how have you been?
Been well. Been busy time.
Yeah.
Market's a little slow right now, a little flat, but always work to be done.
So you just got done. You came down here for the Frac conference, right? In the Woodlands. How did that go?
It was good. It was well attended. A lot of good stuff to see there. It's always fun to get out and see customers, potential clients. It's always interesting to see some of the new technology that is being brought into the industry, stuff that is making the oil and gas industry very efficient and extracting natural resources. It's fun to see.
Nice. Did you find anything exceptionally interesting this year?
There was a lot of, like I said, new technology and dissolvable, degradable types of
Hmm.
technologies, specifically in the alloys, PGA, degradable elastomers, all that. All of those technologies are enabling the hydraulic fracturing world to really advance and get the resources out of the ground really quick.
Yeah. That conference in particular seems that it's grown, over the last couple of years, but it's pretty popular. I hear of a lot of people going to it these
Yeah,
days.
for sure. And I mean, and it's always fun because they do bring some unique pieces of equipment and things like that. I mean, they had like an E-frac trailer and things like that with some of the electronic, or I guess electrically powered frac pumps and things like that. So it's interesting to see how the market's changing.
Yeah, yeah, it's pretty cool. It's oil and gas is always changing and evolving, and it's hard to keep up sometimes. For those that don't know, Nathan and I we go back pretty far. We started relatively the same time at I used to work at Parker, and we worked together at the O-ring division. So I appreciate you coming down and being on here.
Yeah,
So
thanks for having me.
yeah, this is our first episode, and we're pretty excited about it. So a lot of prep. I mean, I would be lying if I didn't say I was a little nervous. So, forgive me, but
Uh,
we should fall into a groove here.
yeah, it all comes natural.
Yeah, hopefully,
Yeah, you
hopefully
got it.
soon. I'm not known for people that know me very well. I'm not a person that is very comfortable behind, in front of the camera or in front of crowds or anything like that. So, but yeah, I do think this is important. I'm curious, when I talk about customers, for you, who is the customer?
That's a great question, right? So, in my role at Parker, I'm a business development engineer. So, business development in itself, we are charged with growing, right? Growing the business. But the engineer side says a lot more problem solving. So we are constantly in with all kinds of different factions and areas and functional groups at the customer. A lot of the interactions we do is with engineering, of course, to make sure that we are solving all the problems that they bring to the market and make sure that we have solutions for those. But there's also a side of the business that's very much commercially based.
Mhm.
So the procurement teams, supply chain functions, procurement, product line managers, operational support, et cetera. So it's a mixed bag, and all those groups have to have to be
Yeah.
clicking properly to make everything go.
A lot of things have to go right for there not to be any issues, right? But with Performance Seals, we're here primarily in oil and gas, and I know you've got a lot of experience in oil and gas, but I've always kind of put the customer is almost like two types of customer, and you have the engineer and the supply chain person, just like you mentioned. And, I'm not as exposed to some of the other markets as I am oil and gas, but do you find that that's kind of is that common in different markets?
Yeah, absolutely. Yeah, I mean, yeah, whether you're going into aerospace, military, defense, power generation, automotive, heavy
Mhm.
duty. I mean, everybody wants to be as lean and efficient as possible. I mean, that is a common practice that you see in the manufacturing world. But all those functional groups make that happen, right? Making sure that we're designing things that are what we call simple by design, but then also having the right strategic stocking inventory and making sure that everything is coming in with the proper quantities at the given times that everybody needs to assemble their widgets.
Yeah. You know, you mentioned simple by design, right? When you think of O-rings, I think most people would say that they seem very simple, right? What's complex about an O-ring, right? And it's interesting because there can be a lot of issues around them, right? But where do you find, with this, the world's changing, right? But there's always a need for O-rings. I mean, what do you see that stayed the same or maybe changed over the last couple years?
Yeah, so I mean, simple by design, I think O-ring is probably what makes an O-ring great is
Mhm.
that it is very simple, right? So we kind of always refer to them as round and round and made of rubber. So you have two dimensions, an inside diameter, cross sectional thickness, and so you don't really have all the intricate design profiles and lip seals and things like that. But an O-ring is a very robust seal. So making sure that that O-ring is not only of high quality but made of the right materials is really where you can differentiate in the market. So just making sure that you know have all the parameters, make sure that you have a material that's it's going to we'll talk about terms like compression set
Mhm.
and things like that, and making sure that they're going to maintain their resilience no
Right.
matter what environment that they're put in. That's really how you differentiate in this market. So O-ring, yeah, it's simple, but there are a lot of things that make O-rings difficult as well. And so you kind of I think you were alluding a little bit to just material changes in general in the market. So there's a lot to discuss there.
Yeah, yeah, there has been a lot of changes, right? I mean, and I'm not trying to dive into these different topics too much right now, but I know the forever chemicals and has been a big topic in the last couple of years, and then there's been a lot of reformulation that's come out of that, and then really coming out, COVID was that kind of happened at the same time as COVID, right? And there was this huge amount of supply chain shortages, and it's really kind of shook the industry up, right? For sure, oil and gas. I mean, I've been entrenched in that, but I assume that it's kind of across the board.
Yeah, absolutely. Yeah, you kind of hit it. There are a lot of changes happening, especially in the fluoropolymer world. But we're trying to do the best we can to stay ahead of it, stay compliant with all of the regulations that have been enacted, and make sure that we just one keep our customers in supply. I think that's the best
Hmm.
thing we can do at work.
Yeah. So your role at Parker, what would you say? Like, what do you do? What's a day in the life of Nathan look like?
Yeah, so I mean, I think business development engineer. So I would say problem solving
Mm.
for sure. Big part of the problem solving is just acquiring information and all the data to make educated decisions from customers. So a lot of time on the phone, a lot of personal interactions, a lot of Teams meetings and things like that,
Yeah.
talking about how the way we're operating a little bit differently. So getting in front of that customer and trying to extract as much information out of them with regards to their application parameters. What do they actually need the seal to do? What issues are they actually seeing from other geometries or other materials? Spend most of my day probably doing that, and then the balance probably doing more project management, new opportunities that come in, making sure that we're working on the right things that
Hmm.
are profitable for my company, but then also this it's really going to impact the customer and make a difference.
Yeah, so I've come into performance sales, and we've had some changes in our team, and one of the things that I've tried to communicate to our team, and really I want it to be part of our identity is that we are problem solvers, right? I mean, of course we want to sell seals and grow and all that, but at the end of the day, we're trying to solve problems, right? Whether it's engineering problems or supply chain issues, right? They're the different set of problems, but between the two of them, but it's you know, when I was in sales at Parker, I have a background in engineering, right? And naturally, I think engineers are problem solvers, right? I did not have sales on my radar at all, and it was kind of interesting because I kind of fell into it, and it's like you're basically solving problems for customers, right? And I never really viewed like sales as that way. I always kind of thought of your typical used car salesman or something, I guess, right? But it kind of changed my perspective of what it is to help to sell a product or help a customer, and that's something we're trying pretty hard to do here is like understand the problems from the customer, and sometimes that's a challenge. It seems like there's a generational change happening right now with our, with people retiring and, both on the engineers, and supply chain. But I have a lot of questions that come in that they're different. You're talking to different people, different names. You have a lot of younger people. I'm curious what kind of questions and,
Yeah.
that you get from both engineers and supply
Yes,
chain.
I think you're the generational change is definitely something that we're seeing, and sometimes you just gotta have to kind of recalibrate or re-educate. Sometimes some of
Mhm.
those newer folks that are coming in don't have a ton of experience with rubber seals or just engineered materials in general. And I know we were talking earlier, there's a lot of folks when they're designing a widget or a big new design
Mhm.
project or something like that, a new tool or valve or whatever it may be, one of the last things they usually think about is, the rubber seal,
Yeah. It's
right?
like
And
the
they kind of,
afterthought.
yeah, exactly. The afterthought. And they come in at the end and they want to, oh, well, I have everything else already designed and spec'd in, and I have this small envelope and I need to fit something to keep
Mhm.
pressure on one side or the other. So, making sure that we're going in and one, letting them know that there's industry experts that will help them, with podcasts like this, good platform for that,
Yeah.
just getting the word out, but then just other resources that are out there. And I think one thing that is important, something that a lot of folks even see potentially even as commoditized as a seal or an O-ring, it's definitely a very technical sale. So
Mm.
you're talking about like your history in engineering, and I think having that engineering background and being able to speak the language, go in and talk with engineers and
Mhm.
have that constant flow of communication it's very beneficial actually to have that background.
Yeah, the most, I guess, successful, opportunities I had, it was usually a scenario where, we've helped somebody so much that you become it's like a technical resource for them, right?
Mhm.
And, not every engineer wants to be the seal expert, right? So it is nice to have people to call on when you need some advice or some direction on
Yeah.
something. But what does that process look like? For you when you get a request in for an application or something.
Yeah, yeah, I think it can go a lot of different ways as
Hmm.
you can imagine. But I mean, just from a most of the time kind of rules of thumb, right? We're always looking for basic application parameters up front. I mean, we have what we call our application data sheet and things like that, where it's a pretty extensive document. We would
Right.
like to know any and everything that could come into contact with the seal. What are the limits? How are you going to test it? How are you going to qualify it, et cetera? But I think, the basics are, hey, what type of seal geometry is it? Is it static or dynamic? That's a big decision making.
Right.
Tree, what temperature profile? Does it require extreme low temp? What's the high temperature? How long is it going to be at those exposures or temperatures? What pressures are you actually going to be
Hmm.
required to seal? Does it have a qualification profile that, hey, the actual seal may only see 10,000 psi, but we have to test it to 15. All those questions like that are very important. I think that's when I go in, I try to shape those conversations, and usually within a 15 to 20-minute conversation, if you have the undivided attention of the engineer, you can usually get that information. And if they don't have it, usually we kind of ask them to go back and see if they can confirm those details with us.
Yeah, yeah, and a lot of times they have like testing they have to go through that's a little bit more intense than what the actual application is going to be, right? So the one thing I found in these different applications, there's like the good enough factor, right? And it's you see that a little bit with there's like a I don't want to say like a natural conflict between engineering and supply chain, right? Supply chain and it's benefited the company, but you want the most inexpensive seal that you can get.
Yeah.
The engineers want the best seal that they can have, so that they don't, have any problems or failures in the field, right? And it's hard to find that balance. And sometimes, in my experience, when we would go in on those application data sheets, it's like here's all the requirements, but in reality, you know, there's like a good enough factor there where it's like, hey, if you're going to hit everything you've listed here, that's going to be a pretty intense seal that is expensive but you can throttle it back a little bit and have something that's good enough. And an example that comes to mind, it's like, the HMBR seals, sometimes we'll have a request that it's like, hey, this seal needs to go to the 350 Fahrenheit,
Mhm.
right? But it only needs to stay there, for a few minutes,
Right.
which is above the temperature limit of HMBR, right? And so it's like they don't want to move to an FKM.
Yeah.
it's like, how do you balance that, right? Is that something you've experienced or?
Yeah, absolutely. I mean, and it's always pushing the envelope without having to pay a premium, right? And
Mhm,
so what we typically do is we always fall back on, hey, we make the determinations or the recommendations based on the available technical data that we have. And,
mhm,
you know, we are lucky enough that we have some really good test labs and things like that that we can go back and, you know, perform some different testing or heat aging or fluid immersion to see how HMBR materials or a given compound may react.
mhm,
And so, you know, all those are ASTM or ISO test standards,
mhm,
and we make educated decisions tried, you know, based on that. You know, hey, if the customer only needs it to last for a few hours, which is we find that a lot. Hey,
mhm,
it's going to go down in the hole in the ground or downhole,
right,
and hey, the operation is going to be a total of 8 hours in length, right? Would this material work? And you know, we try to make educated guesses and
right.
engineering assumptions, but at the end of the day, we honestly do rely on them to do the functional testing and perform that. Now, I mean, we usually have a pretty good indicator of yeah, we think this is a pretty good solution, but at the end of the day, they have to test.
Yeah, sometimes that was it's interesting because it's when I would have some of those conversations with people throughout the years that sometimes they were surprised a little bit. They're like, "Oh, well, I thought you could tell us for sure that this is going to work," and it's like, well, of course, you always want to, test the waters a little bit, right? Like you want to back it up with real testing in their application, right? So it's like, we're pretty confident based on our experience this is going to work, but you need to test it, right? Most of the time it does work. Occasionally you get these applications where you're really pushing the limits, and in a way those are much longer to get something that works, but those are many times that, for me at least, they were the more exciting ones because you're really pushing the limits of, the materials a lot of times. Sometimes it's that physical aspect of the seal, but that's when you start, needing and having cause for, new material development and things like that. So,
Yeah, correct. And I think there are a lot of reasons that a seal
mhm,
might fail, right? So, hey, we try to make the right recommendations for like the gland design and making sure all your mating hardware are properly toleranced and surface finishes and
mhm.
lead in chamfers, even just the might have everything right, but you maybe damage the seal during install. I mean, that honestly becomes
It happens a lot.
yeah, it can happen quite often without the right lead-in chamfers and surface finishes, deburring all the tools, etc. So I think that's a whole nother conversation, and we just try to make sure that anytime that we have a customer that may be having those difficulties, that we go into it with open mind and understand, hey, it's nobody's trying to intentionally make the seal fail. It's nobody's
Yeah.
fault. It's just let us get the information and then see if we can find that root cause and diagnose it.
Mhm.
And
I had a, situation a couple months ago where we had a customer that had, it was a pretty large seal. I think it was close to like 30 inches. And, no, it wasn't an O-ring. It was more like a polypack type design, but we were recommending an elastomer, and, it was gonna be a seal that required a new tool. And nobody ever wants to pay for tooling, especially that size, which is understandable. But so they elected to go with a machined option. So it was like a machine plastic, right? Like a urethane. And we kind of warned them whenever that it's like this is going to be extremely difficult to install, right? And sometimes you lose sight of that when you're just at the engineering stage and you're looking at things on paper, and it's like, oh yeah, it fits, it's in its groove and everything. But we found out later that they did go that route and got some machine ones in. There was one of the people that was putting the equipment together. He basically like cut the end of his finger off installing it, and it's stuff like that that it comes with like experience, I guess, right? And you can always make the recommendations, but I'm finding that that's starting to. I don't know. It's like happening more because there's this big generational change happening where like you have the older generation that has a lot of that experience. They're retiring, and the new engineers and supply chain people are coming in and finding themselves in these different situations, and kind of repeats itself. I'm assuming every so many years, but I think me and you are probably somewhere in the middle there,
yeah, I would agree. Yeah, so I've been
getting older every day, right?
yeah,
But
15 years, so it's hard to believe sometimes. Yeah.
but yeah, it's I think that's kind of why are we doing these podcasts and stuff. It's that's one of the goals is like trying to, educate some of the people that, might not have as much experience and, or at least direct them where do you go get it. There's, when I started going down this path, I found there's a lot of resources on the internet and different places. There's a lot of design guides, but there's not a lot of videos or how-to videos. And I don't know about you, but I'm definitely I go to YouTube all the time for like how to do whatever. I do a lot of DIY stuff at the house and all that and working on my vehicles or whatever. But that's kind of like non-existent for seals, right? And probably a lot of industrial applications, right? So I think that's a gap we're trying to fill and, provide just another channel for information.
Yeah, for sure. And I think that's, I mean, we've tried to do a little bit of that at Parker. We've got some stuff out there. My initial claim to fame was the infamous "How to Lubricate an O-Ring" video. So you can look that up. That was an
Yeah,
old Nathan Sowder, almost 15 years ago now. So that was,
make it go viral, man.
yeah, back when I had hair.
Oh man. Well, so what would you say to the younger generation? Like, what's a takeaway you would leave them with?
What I would say is, I think we talked about this quote earlier, but it was the most expensive seal is the one that fails.
Yeah,
So
yeah,
when you go through and you're trying to design something that's going to be used in a application, whether it be critical or not, a very inexpensive component like a seal or an O-ring can cause a lot of non-productive downtime,
hmm,
safety concerns even, and the like. So just knowing that there are industry professionals out there that they can lean on to help them make those decisions, I think that's a big takeaway I take.
yeah, yeah. It's important, and that I mean, documentation and traceability and all that. It's like one of the that's providing seals and being a distributor, and my experience at the in the manufacturing world as well. Like that's almost harder than dealing with the seal itself. Is like making sure you have the documentation correct and everything matches. And but it's important, right? You gotta once you get the right seal designed in there, make sure you're getting that seal every time, and when you need it, right? So that's the supply chain, factor is always on time delivery, and and then there always is initiatives to reduce prices and lead times and all that stuff. And that's one of the things that we try to focus on here. We have a lot of inventory, and kind of it's like the example I use sometimes with some of our customers. It's like you don't typically, if you need to buy a can of soup, you don't typically go to Campbell's, right? You go to the grocery store and get
Yeah.
a can of soup, right? So that's kind of the same model that we have, and but we have a lot of capabilities to kit things and do stuff like that. That depending on what our customers need, but
Yeah, I think you said something there that's really important too. It's like not all rubber compounds are created equal, right? So, hey,
mhm,
like just when you see the generic N70 or fluorocarbon 90, there's a lot of materials that could fall in those ranges, but you get a lot of different performance envelopes and characteristics in that very generic
yeah.
characterization. So, making sure that you have stuff that is going to fit the need of your application is really important.
Yeah, you mentioned earlier that some of the new technologies that have been coming out. I mean, what kind of technologies have you? I mean, have you been working with? I guess over the last couple of years, like what kind of rubber technologies are there?
Yeah, so I mean, so this industry that you work in,
Hmm.
mostly oil and gas, has really been pushing the frontiers of science, so to speak, over the last 10 to 12 years specifically. But new materials and things like that that are able to withstand not only higher temperature. A lot of folks are saying, hey, with their drilling and formations and plays and deeper wells that
Hmm.
are higher temperature, but then also the advancement of low temperature technologies. And there's some additional benefits of low temp that you can see in the combination of a low temperature and high pressure combination. So there's some of that that's out there. Definitely a chemical resistance. So as the industry morphs and tries to make their processes and functions more efficient, there can be some additives and things that are added to drilling muds or completion brines and the like that
Yeah,
really,
that's super hard to keep up with.
yeah, that's very difficult to keep up with. And that's really caused some advancements and some new material technologies that are more
Hmm.
chemically resistant. They're going to, maintain properties when they're exposed to those fluids, et cetera. And that's going to give them better life in the application.
Yeah, yeah, I know, and the last couple of years, I've seen, a couple of them I would probably name as the BRE, which is
Mhm.
the base resistant elastomer, and, kind of fills a gap between FKM and AFLAS, right? Very chemical resistant and, very well-rounded, I would say cost-effective material as well. And then the dissolvable, I mean, that kinda it's really got a lot of traction, right? I
Yeah.
mean, both, kinda have dissolvable metals. It's kinda where it started out, but, quickly made its way into the elastomer world, right? So I know Parker makes some pretty good, dissolvable elastomers, and then you're right, the low temp materials, and sometimes it's you wouldn't think that oil and gas has a lot of low temp, but you know, you basically end up using it with high pressure, right? So some of these subsea, really high pressure, people going up to 20K, on some of these systems, there's a glass transition temperature
Exactly.
changes pretty significantly when you add that pressure,
Yeah.
and that's the kind of stuff that a lot of times people don't necessarily know that is even happening, right?
Yeah.
And
Exactly.
I know for a long time, VG109 has been a big staple in the oil and gas world, and it goes down to correct me if I'm wrong, but negative 40, I believe.
Yeah. Negative 46 Celsius is kind of like the TG. So it's, yeah, well, static environments. You can get
Yeah.
down there minus 50, minus 55, depending on what fluid you're
hmm
sealing and the like. But yeah, it's a great material.
But I think a VX365 has come out,
Mhm.
and it pushes the boundaries on the low temp side. I know we've had a few applications where VG109 was kind of on the edge there of sealing. It works sometimes, but not all, because you're
Yeah.
basically flirting with the edge there, right? So VX365 is like it's been a great solution for some of these applications.
Yeah. I agree.
So,
And the cool thing about VG1 is something specific is the breadth of product offering. So, I mean, we've talked about O-rings
mhm.
quite a bit here, but there are a lot of other steel geometries and things like that that are out there. And being able to spec in one material and get a full product suite,
Yeah.
whether it be lip seals or custom molded shapes, large elements, rubber to metal bonded, et cetera. That is another really goes into that simple by design, spec in one compound and be able to get all those products. That's where VG109 excels.
It's funny you bring that up. There's That's something I've run into in my career, right? Where you have some materials and you don't necessarily think about the manufacturability of them, right?
Mhm.
Like, you have an extremely extrusion resistant material, which is a very common need in oil and gas as you go to high pressures, but the it's very hard to process a material
Can be, yeah.
that's not not very it's made to not extrude and not move, right? And a lot of times the process for manufacturing it is extruding it, right? So there is many materials where there's only a few select geometries that you can really produce out of that. So, but VG109 has been a pretty strong staple in the industry, and is used in a lot of different geometries.
Yeah.
So, but you can buy, and I think another nice, I've seen a few applications where we actually bond it to metals and things like that. Like a metal piece will be used as a backup, or to close off the extrusion gap. So,
Yep.
it's a very good material. We sell quite a bit of it. So, but well, it's exciting to hear the new stuff. Is there any? I mean, I know hydrogen and some of these other areas have gained a lot of traction in the last, I'm gonna say 2 or 3 years. Carbon capture, that kinda goes hand in hand with some of the oil and gas applications, right? But it kind of shifted the focus, it seems like, and the questions now we're starting to get a lot more questions about, gas permeation and
Yeah.
and those types of things, and, I mean, have you had similar experience or
Yeah, no, absolutely. And I think that's you talk about like changes in the marketplace and kind of newer developments and technologies and platforms. I mean, obviously, like CO2, carbon capture, hydrogen, definitely something that a lot of people want to talk about. A lot of those gaseous applications present some of their own challenges. So, some of the stuff that we're going to run into, obviously, is when you're sealing a gas versus sealing a liquid. Surface finish is very, very important. Talked about permeation or permeability of that
Mhm,
gas through thermoset elastomers and the like. I mean, that always comes into play. So making sure that you're choosing a material that has a really good permeation resistance.
mhm,
And then you have other phenomena that we run into, like rapid gas decompression
yeah,
resistance and things like that. So, yeah, what I would say is if you do have those applications, we have a suite of materials that we've done some testing on, but we always are interested to have those conversations with customers to see exactly what they would like to see, because we're kind of limited sometimes on what we know, and so having that and pulling that from the
Mhm.
customers is really beneficial for both parties.
Yeah, yeah. Do you find it's difficult to get customers to open up about some of the problems that they face?
What I would say is a lot of customers, when they approach us, a lot of times they may or may not have all of the details. It's more of an exploratory call. So it's, hey, we're calling Parker because Parker's kind of seen as a leading expert in the
Mhm,
sealing industry. And so, hey, we're just reaching out to see, hey, what do you know about, this new market frontier or something like that? And those are always really fun calls to have, right?
mhm.
Because a lot of times we're kind of more brainstorming, and it's where the
Yeah,
engine really where the engineering side can
that's the
come out.
exciting stuff.
Exactly. So you can
Yeah.
kind of talk about and bounce some ideas off of, and hey, if we want to establish a test protocol to evaluate existing offerings, which is always usually the first path, or like something that you talked about earlier is, hey, is it something that we need to look at developing a new compound, family or technology platform to meet?
Mhm.
And that's a lot of those developments and things like that come out of those early exploratory calls.
Yeah, those are exciting, and you kinda like you said, you feel a little bit more like an engineer in some of those calls, right?
Yeah.
Where you're, like, actually, thinking you're, like, solving problems that there's not readily available solutions to, right? So
Right.
those are the exciting ones. What are some of the more common, I guess, challenges or problems that customers bring to you, I guess, or they run into?
Well, I mean, recently we've had a lot of gaseous stuff, like you said, with
Yeah.
CO2 resistance. We've got customers reaching out to us for certain chemical resistance. There's a lot of things that center around methanol and different solvents. A lot of folks looking at high pH completion brides and things like that. So wanting to know more compatibility wise, hey, what does Parker have that would be able to withstand this media at this temperature, or something like that. So
Mhm.
those are what I would say is very common in what we do is just we're seen as kind of the material experts.
Yeah.
That's a core competency of ours, is making sure that we bring the best materials to the marketplace. And I think people really look to Parker for that. And so we have a lot of those conversations.
Yeah, I think one of the things I always thought was a huge benefit of Parker and is the breadth of the technology and the markets. And I mean, I know some of the oil and gas materials that we use
Mhm.
today did not originate from they originate in different markets. Like I know
Yeah.
aerospace has a lot of cold temperature application,
Yeah.
requirements as well. But it's nice because have some when you have some of these problems brought to you, it's kind of like you can kind of pick something from a different market and you're like, hey, this might be a good fit over
Yeah.
here. So it's interesting seeing how the technology overlaps and the different markets kind of have similarities between them.
Absolutely, yeah, and that's it is a benefit of Parker being very diverse, a lot of different market spaces, aerospace, defense, automotive, heavy duty diesel, and we have a lot of things that you know actually can see some crossover in areas that
Hmm.
don't always highlight themselves initially.
Yeah, good. One last question. How would you describe a good distributor? What does good look like?
Yeah, for sure. So Parker, I mean, yeah, we have a ton of good distributors. Our MG distributor network, greatly respect and work with a lot of you guys.
Mm-hmm.
So the big thing though is like making sure that you have that open lines of communication. I think that's paramount in
Hmm.
all instances, because when you have that communication and we know what you guys are working on, or if you have the ability to reach out to us when you have a question or the like, I think that is number one. And then two is, hey, we're all on the same team, right? Let's say
Yeah.
we definitely look at our distribution network as kind of an extension of our Parker sales force and engineering network. We got a lot of distributors like you guys have
Yeah.
engineers on staff, and it's really good to have that background, that history. So making sure that we can collaborate
Yeah.
and do that, I think is really
Yeah, no, we're excited to have partners like you all. I mean, it gives us a lot of horsepower, I guess, so to
Mhm.
speak, for engineering and a great offering materials and very quickly if there's questions I can't answer, it's like I have a great team to go to, and like yourself, you're always available and happy to help. So it's I've worked with you for many years, so I know we've had a lot of good successful sales calls together, and it's been fun. So But hey, I really appreciate you coming in today, and I enjoy talking about these things with you. So, and until next time,
Hey, for sure. Yeah, I really appreciate you having me on. It was a good discussion. Look forward to doing it again.
thanks.